for parabolas, here's what you need to know. This is like the main piece of what you need. Negative b over 2a. That's going to be your x value for your vertex. That's also going to be your axis of symmetry. Okay? We got to know that. All right? Once you find your x value, what do you do with that value to find your y? Plug it into the problem. That gives you your vertex. Okay? So if you can work number 3 and draw it, then you should be able to do the multiple choice ones whenever I ask you to just pick the right one, right? So for this one, we would say our x value is negative b over 2a. What is my b? What is a? So my x is 2. So what do I do with that? Plug it into my problem for x. That's 2 squared is 4 times 2 is 8 minus 16 plus 5 is negative 3. You have a calculator, so shouldn't be that bad. So your vertex is 2, negative 3. So I can go ahead and place that right there. What's my axis of symmetry? X equals what? So you should have a dotted line. 1. There. This graph opens up or down? How'd you know? Leading coefficient is positive. Unmath that. The first number is positive. So it opens up. Okay. Now you need one more point. Right? I need one more point. So what is smart? So yes. If x equals 0, then f of 0, so I'm finding my y value. 2 times 0 squared minus 8 times 0 plus 5. So another point that I could plot would be 0, 5. Okay. Remember, 0 is always the easiest thing to do, right? I picked another x value. If you want to pick 1 or 2, do it. I don't care. Okay. But you have to do the math for that. 0 is just easy math. So 0, 5. What's my other point? 4, 5. How do we know that?
Well, I think you should look at the problem and see what C is, and then what it is. Like, put it in the graph.
Sure. Because you're plugging in 0, right? Yeah. That's fine. All right, so I knew that I had to do 4, 5 because it needs to be equidistant, right, from my line of symmetry. Okay, equidistant, that means the same distance, right? So I went 1, 2, so I'm going 1, 2. So that would be my graph. Okay. Those are the way that all of these work. And you would do the same thing for multiple choice. Multiple choice is a little bit easier because it's multiple choice. So you can use process of elimination on those, okay? This is where most of your points are going to come from, obviously, right? You don't need to miss anything on parabolas. That's silly, okay? We don't need to miss anything on parabolas. This is where all your points come from. Probably, I think, 70 points. Yes, a lot. But that makes sense, right? 30 points left of parabolas, and then literally everything else we did is worth 70 points. So y'all kind of huff and puff, and it's like, what other logical thing would make sense? Nothing, okay? How do I do synthetic division? I'm gonna have to do it over here. You do your chart. I think that's what you said. Okay, your problem, I'll write it. No. You do not have long division. There's your problem. What number goes in the left-hand corner? And then how do we know that? Bless you. Right. Opposite of -2, right? And then I need to answer this question. Are there any x's missing? Which one? X squared, right? So I'm going to go to my problem and write plus 0x squared. If you don't write it on your problem, you'll forget it. Okay? Then I'm going to list my coefficients. So what do I start with? And then. Then I run my procedure. What's my first step? I'm going to assume that all of you said bring down the 3. Because I didn't hear you. 3. Then what? 3 times 2 gives me 6. And then I add down and get -1. Then I multiply and get -2. And then I add down. And then I multiply and get -4. And then I add down. And then multiply. Just like that. Okay. Now I need to write my answer. And the dark blue numbers that I found are my new coefficients after I've divided. Okay. So I just need to go in and write x to the whatever behind them. So I have 3 and then x. And then what is my rule for what power I start with? 1 less than what my problem gave me. My problem gave me 3x to the 4th. So I start with 3x to the, yeah. And then you just go down. The last number should always be your what? Yeah. And remember that I don't have any problem with you just writing R to them. R -7. Not a big deal. That's going to be your first question. Different numbers. Same thing. Okay. The main thing that people miss is they don't put the 0. You do 3, -7, -4, 9. Got to remember to put your 0. Okay. The next problem says, find the zeros of the polynomial and list the multiplicity of each. And I give you this function. Okay. I want to find the zeros. So I want to find, if I plug in 0 for, sorry, I just gave you the first answer is one thing about. What numbers am I going to plug in for x that give you 0? Okay. So you don't have to factor this. And the one on the test, you don't have to factor. It's going to be almost just like this. Set each piece equal to 0. And solve for x. Those are the zeros of the polynomial. If you plugged those numbers in for x, you would get 0 every single time, right? Okay. The multiplicity is the what? how many times the answer appears. So what does that correlate to in my problem? The exponents, right? So what's the multiplicity of 0? Of 7? Of -5? Yeah. This is your answer. That's all you have to do for that problem. It's going to be the second problem on the page. Okay? And if you notice, this goes in exact order with how we worked them in class. We started with synthetic. We actually started, I guess, with finding the zeros. Then we did synthetic. Then we moved to number 11 that says, nope, number 12 that says solve the equation given that 1 is a 0 of your function. Okay, so here's my equation. And I give you that 1 is a 0. If I plug 1 in for x, I get 0 equals 0. Okay? I want to know everything else though. So what do? You make a little chart. So I'm using what? What is the little chart thing called? Yeah. So I'm doing synthetic division first. And I'm going to put 1 in the bottom left-hand corner because that's a 0 of my function, right? And then I'm going to list my coefficients. So I have 2, -15, 6, and 7. I list my coefficients, right? My first step is to bring this 2 down. Then I'm going to multiply and add down and multiply, add down. What would I do if I didn't get a 0 for that in this problem? For my remainder? You are what? Wrong. I gave you that 1 is a 0 of your function. So when you put 1 down in that bottom left-hand corner and you do synthetic division, you should get a 0 for your remainder. If you don't, you did something wrong. Okay? So what do I do with this? What? Into what? You answered, so you got it. And you set it equal to what? So you're going to factor and solve. That's a hard trinomial. I don't know if I give you a hard or easy on your test. If I give you a hard, I assume that most of you will do bottoms up. Is that right? Okay. So let's just work it like that. You multiply 2 times 7 to get 14. You factor the easy trinomial that way. Then what? Simplify your fractions, and if you can't, you're going to move it to the front. 14 over 2 is 7. So I factored my hard trinomial. What do I do with that? -1/2 and 7. You subtract 1, divide by 2. So your answer will be -1/2 and 7. and 1, but I won't count off the other one. Okay? So if I give you a 0, you're going to do synthetic factor solve. That's what you need to be able to recall on your test. If I give you this type, what do you do? The process is not that bad. Synthetic division, factoring, and solving. We factored and solved day 2 of class. Okay? But you need to know, if I give you a polynomial and I give you a 0, synthetic factor solve. Okay? The next one is possible zeros, question mark. Yes. So number 13 says list all possible zeros. Okay? If I just tell you to do that, make a list and stop. All I'm telling you is to make a list of all the possible zeros and stop. How do I find possible zeros? Factors of your constant over the factors of your coefficient. Factors of the last number over the factors of the first number. Okay? If you need to demath that a little bit. Okay? What's the problem that I give you? This is the problem that I give you on your worksheet. What are the factors of my constant? What are the factors of my leading coefficient? Am I going to count off if you don't do plus or minus? Yes. It's a very agitated yes from the corner over there. Okay. So now I'm going to put all of my numerators over 1. Then I'm going to put all my numerators over 5. Right? So I'm going to do this. Wrong way. I'm going to do this. Then I'm going to do that. Right? So if I'm going to do 1 over 1, that gives me 1. And then I do 3 over 1, that gives me what? Yeah. The first thing you're going to do every time is list your numerator again, because you're always going to put them over 1. Okay? Then you're going to say 1 over 5, that gives me a fifth. 3 over 5, that gives me 3/5. There's your list. That's what you put in your answer blank. You don't have to do anything else. All your possible zeros. Okay? The next 2 questions, 13 and 14, ask you the same thing. All right? On your test, I don't know what happens, but normally you guys get the first one right, and then you don't even attempt the second one because it looks different. Okay? So if you're looking at your worksheet, it says find all zeros of the polynomial, and then I give you the polynomial. That's what 14 says. 15 says solve the equation, and then I give you the equation. That's the same thing. Okay? This one was section 3.4. This is when we need to do possible zeros, synthetic factor solve. Okay? Which you've already done in the previous problems. You just did possible zeros. The problem before that, you did synthetic factor solve. So now you're just going to put it all together. Okay? So let's do this one. My first step is what? Possible zeros. That wasn't English. So that's the factors of the constant over factors of the leading coefficient. Okay. What's my constant? 10. What are the factors of 10? What are the factors of 3? Uh-huh. I'm gonna make a list. I'm gonna put all of these over 1. So 1 over 1, 2 over 1, 5 over 1, 10 over 1. I'm gonna go back through and put them all over 3. So that's 1/3, 2/3, 5/3, and 10/3. So there's my list. How am I going to use the list? I'm going to go to synthetic division. Here's my coefficients. I'm going to go down my list until I find a remainder of what? 0, right? If I find a remainder of 0, then the number that I put in the left-hand corner is a 0 of my function, right? That's how it works. So I'm going to start with 1. So I have 3, and then I multiply, add down. I found it, right? If I got a remainder of 2, what would I do? What would I put in the bottom left-hand corner? -1. If that gave me 0, then I would stop. If it didn't, I would move to +2 and then -2, okay? I don't think I'm mean on your test, okay? So you found it. So now I'm going to turn this into my new polynomial, just like I did on the last problem, right? When I gave you a function, I'm going to factor this. You can do bottoms up if you want to. That takes too much time. That's using trial and error. Okay. That's not your jam. Just do bottoms up. Okay. Now what do I do? What's my answer? And 1, right? Where'd I get the 1 from? Yeah, 15 minus 2 is 13. Okay. The next one works the same exact way. Okay. All of the answers that you get should be where? In your possible zeros list. If it's not, sounds weird. Okay. Any questions? So I'll give you another one of those. I just ask it differently. Then you have your inequality ones. I'm giving you 2 of those. One of them will be a fraction. The other one will just be a polynomial. We're going to do 16 and 17. So that leaves 18 and 19 for you to do by yourself. And I would like maybe know how to do this. Everybody good? 18 and 19? Maybe those are exact ones I would know how to do. I don't know. Just a hint. Okay, this one. I guess I'm doing 17 first. that's the one I wrote down. Okay, 17. What's your first step? These all have steps to them. It needs to be in standard form. What's that mean? Okay. 0 on one side, and the other side is factored, right? This one's fine. You can't factor x minus 5 or x plus 7, and you have 0, okay? Then what? Yeah, numerator equal to 0, denominator equal to 0. What do I do with those two numbers? Put it on a number line. Okay, let's name those intervals. This one's negative infinity to negative 7, negative 7 to 5, 5 to infinity. What is around 5? How'd you know? Yep, your numerator depends on your problem, right? So I gave you greater than or equal to. That means anytime you write a 5, you need a bracket. What's around negative 7? Why? Right. Your denominator, what? Your denominator always gets parentheses, no matter what. Okay? It doesn't depend on the problem. It depends on the rule that it gets parentheses. So anytime you write negative 7, you should put parentheses. Okay? Numerator depends on the problem. Denominator always gets parentheses. Now what? I'm going to choose numbers in those intervals. So I'm going to choose negative 8, 0, and 6. Can you choose whatever you want? Yes. You're going to have to plug those green numbers into that green inequality. So if you want to pick negative 47, you have to plug that in. Unfortunate. Okay? Just be smart about it. Pick the next number on either side. If you have 0, pick 0. That's easy, okay? So we're going to plug in x equals negative 8. So negative 8 minus 5 over negative 8 plus 7. And we want to know if it's greater than or equal to 0. That's negative 13 over negative 1. Is 13 greater than 0? Yeah, so that's true. Then I'm going to plug in 0. Negative 5/7 greater than 0. Oh, that's close. What is it? 6. 1/13 bigger than 0? Yeah. So I got on my number line true, false, true. I only want the truth, right? What goes in between them? That goes in your blank. Those work the same way every time. All of these work the same way every time. Okay? What should be true about your number line and the true and the false and all that stuff? It should be alternating. So if you start with true, you should have true, false, true. If you start with false, you should have false, true, false. Okay? At the very least, check the first one and the second one to make sure you're right. Because if you got true, true, then something's wrong, right? So don't just check the first one and think that you're right. When does it not, just for fun? When does it not alternate? It was the one that had the special case on it. No, I'm disappointed. When it has what? When it has multiplicity. Okay. You don't have multiplicity on your test, so they should alternate. Any questions on that? Okay. What about systems of equations? That's section 5.1. I'm gonna give you 2 of those. Yeah. Do you want me to? It works the same way. I'll do it if you want me to. Number 16. Okay. I need it factored. Factors of 36 that add to -5. I need my numerator equal to 0 and my denominator equal to 0. Do I have a denominator? No. What do I do with -4 and 9? Put it on a number line. Let's name our intervals. What's around both -4 and 9? Parentheses, why? There is not an equal to sign on your problem, right? It's strict. So parentheses everywhere. Then what? I'm going to pick numbers and I'm going to put them in my true false chart. And I had 0. Right? So I went and grabbed this. That's what I plug into. And I think on the completed worksheet, I didn't factor it. So that's my bad. On one of them, I can't remember which one. I think it might be this one. Let me look. I have it right here. No, it was on. Oh, did I make that up? Just kidding. I didn't screw up. I thought I did. What? Someone has their hand up. Yes. Oh, I didn't mean to. Less than 0. Sorry. Didn't mean to. I was trying to figure out where I screwed up, but apparently I didn't. All right, so we plug in -5. Less than 0. -36 less than 0. And then less than 0. So I got false, true, false. I only want the truth. That's yours. Everybody okay? Solving system of equations. Um, oh, yeah. Right size. -31. That's number 20. Okay. One of them on your test is going to make sense for you to do the addition method. The other one is going to make sense for you to do substitution. You can do either one. I don't care which one you do. Okay. Which one do you think it's going to make sense for you to do substitution on? The one on the right? Why? It's already solved for x over here, right? So it would make a whole lot of sense, okay, for you to say, all right, if x equals 2y plus 8, then 5 times x, which is 2y plus 8, minus 4y equals 34. I substituted in 2y plus 8 for x in my other equation, and I can solve. Add like terms. Y equals -1. How do I get what x equals? Plug it back in. Right? So x equals 2y plus 8 more. So that would be 2 times -1 plus 8. So x equals 6. I found one, plugged it into the other one. Any questions on that? Hold on one second. For this one, it makes more sense for you to do the addition method. That's when I want to make one x or y equals 0. Okay, so if I want to make, let's just say I make my x's, I want to 0 out. Okay, the first one says 4x. If I multiplied this whole second line by -2, I would have, so I have 4x plus 3y equals 3. That would give me -4x plus 10y equals 62. You could have zeroed out your y's and multiplied the top fraction by 5, or your bottom fraction by 3, and you would have had 15y minus 15y. That would have zeroed out your y's. You can do whichever one you want. Okay, I picked zeroing out my x's because I just had to multiply one equation. Doesn't matter. Do whatever you want. So you get 13y equals 65. Divide by 13. And y equals 5. What do I do with that? Plug it into what? I want to find both. So let's say the question says find x and y. That's what it says on your test. Plug it into the one you didn't touch. Okay? If you touched them both, go back to the original one that's printed on your test that you didn't do anything to, pick one of them and plug in your Y. And X would equal negative. Yeah. Because I wanted to zero out my X's. The only way that I can do that is I would have to say, so this one says 4X. I want this one to say negative 4X so that I can do this. Okay. If you wanted to zero out your Y's, that's fine. You would have multiplied by 5 and then 3, because that would have given you 15Y minus 15Y, which is 0. Okay.